I'm Shubham Goyal along with Varsha Sharma. I'm co-presenting on seamless SSO configuration in Confluent Control Center for enhanced streaming authentication with CFK. We are from Confluent, so we both work in a Confluent support team. So now let's get back to the presentation. So in this session, we'll be talking about single sign-on, which we are configuring in Confluent Control Center. And we are deploying it via Confluent for Kubernetes, which is CFK, for seamless authentication. And we are integrating it with Microsoft Azure Intra-ID. So the reason we are doing it is to simplify access management while maintaining enterprise-grade security. So this is the agenda for the session which we will be discussing. First, we'll be laying the foundation. So this involves setting up Azure Intra-ID. This is our identity provider. So this involves registering an OIDC client application in the Microsoft Azure Intra-ID, and then generating the authentication credentials. So this authentication credentials is what going to help to verify users' identities in the IDP. Then we'll configure CFK. So in this, this is where we'll be integrating it with the IDP. So this is where Microsoft Azure Intra-ID will be, the properties of the Microsoft Intra-ID will be in the CFK deployment file, and we'll also implement the necessary security configurations, and we'll add the role bindings. And at the end, we'll run our deployment, and we'll test the authentication flow, where you can see that user can seamlessly log into Confluent Control Center through SSO. So why single sign-on? That is a big question. So there are a couple of reasons why people want to use a single sign-on. First is enhanced security. So with single sign-on, you can mitigate all the risks that are associated with managing multiple passwords. And also, it helps you in providing that authentication is managed by a trusted identity provider. And so this is the flow, what actually SSO login looks like. Then for centralized user management. So centralized user management, it helps administrators in controlling access for their organization, and it also helps in onboarding and deboarding the users across the organization. So basically, it simplifies the access management. And the third one is support for modern authentication protocols, OIDC. So we are using here OIDC, that is OpenID Connect. It's basically OAuth Framework 2.0, which is the most modern authentication protocol and standard used by cloud identity providers. So these are the major key components which we will be working in our, which we have deployed in our architecture. So with respect to Confluent Platform, we are running a Kafka broker that is running in a craft mode. It's basically our messaging backbone, which is a high performance. And then we have a CFK. CFK is basically used for managing our Confluent components through API-driven specifications, which is the Kubernetes native operator. And then we have MDS. MDS is our centralized security and authentication hub in the Confluent Platform. And then Confluent Control Center. Confluent Control Center is just a web-based UI, which is used for monitoring and managing the Kafka clusters. For identity and user stores, we are using LDAP and Azure Intra-ID. LDAP is our traditional enterprise directory, which is used for user authentication. It will be used by MDS, metadata service, for authentication and authorizing all the CP components involved. And Azure Intra-ID is our cloud-based identity provider, which will help us in enabling single sign-on. And this is what will be used by the C3 to authenticate via SSO. And at the end, our client access will be the web browser through which we are going to access our Confluent platform. So user interface, so that is basically our user interface through which you can see that how easy or how seamless it is that through a web browser, through a single click, you can directly access your Confluent platform components. So this is the main flow which we are gonna which is gonna happen in the backend in our deployment. So there are 4 major components here. One is browser, then C3 backend, then MDS, and OAuth server. I'll just explain you how actually it will look like when the calls are made. So first is browser. So browser is where you will open your Confluent Control Center UI, where the authentication request will happen. So if you see, when you are clicking on, when you are opening Confluent Control Center, and then you're asking for authentication. So this request will go to C3 backend. Then C3 backend, since MDS is our centralized authentication hub, so C3 will pass that request to MDS. Now, in our deployment file, MDS will check for, okay, how to authenticate C3. And then in the C3, it will see that, okay, for C3, it is configured as an OIDC or an SSO authentication. And also in C3, we'll provide all those SSO configuration details that we'll see later in the deployment file. But once the request reaches MDS, MDS will check, okay, how to authenticate C3. It will have an auth URL configured with it. It will pass it to the C3 backend, and C3 backend will later forward it to the browser. Now, browser have the auth URL. It means that browser knows where to authenticate itself now. So with this auth URL, browser will authenticate itself to the OAuth server. So this auth URL is basically the authorization URL for the IDP. And in this authenticate process is what you will see that this is where user is entering his username, password, and multi-factor authentication if you need a code as well. So this part is till here. You can see the authentication request happening. And once the user is successfully authenticated at the OAuth level, then OAuth will pass the OAuth code to the browser. So basically, if let's say I have logged into the identity provider, now identity provider it has successfully validated the username, password, and extra code what I have shared it with that. So it will give me an auth code, as well as it will redirect me to the application to which I am intended to log in. Like in this case, it's C3. So my identity provider will redirect me to the C3 endpoint, this with the auth code. So if you can see, this is the format of the callback or redirect URI, in the format which it should be. And then auth code is the token which is generated on the successful authentication of the user here at the OAuth server. Now, this is the part where now browser have the auth code here with itself, and then browser will pass it to the MDS. Now at MDS has the auth code now. Now MDS, as we know, is the only component in the CP which is responsible for authenticating through the IDP or the identity provider or any user store per se. So now with this auth code, the MDS will do a post call to OAuth server, that is /token. We'll configure the token endpoint URL also in our C3 configuration. And then once the post call is done to the OAuth server will return an ID token and a refresh token. So let's talk a little bit about what is auth code, what is ID token, what is refresh token. So auth code is basically the authorization code. So when a user successfully authenticates itself through the auth server, then it just that is the confirmation that, okay, the user has been successfully authenticated. It's basically a temporary, short-lived code which is useful in getting the ID token and the refresh token in exchange of it. And auth code is only it can be used once. You cannot use it again. So yeah, that is basically the auth code. The purpose of auth code is that it doesn't. In SSO, we don't want the application to know about the credentials, what the user is entering. So that is the purpose of auth code, that it just doesn't let the application know about the credentials, what the user have entered. And then we will have the ID token and refresh token. So ID token is the one here which will have the identity of the user. So this will be returned by the auth server, and the identity of the user will be in the form of claims. Claims are basically an key value pair which helps in identifying about the identity of the user. You will have certain claims which you can see like subject, issuer, token, expiration, or something around. Those are the claims which you can see in the key value pair. And then you'll also get a refresh token. So refresh token is optional. You can configure in your deployment whether you want it or not. But refresh token is something which helps in making the authentication process pretty seamless, because if you have configured the refresh token, you don't have to, it doesn't require user logging multiple times, because once you'll have a refresh token, then even though the ID token is expired, the MDS will again do a post call to the OAuth server, and then it will get a refresh token again on the basis of a refresh token. You don't have to log in again to get the auth code and then do a post call to get a refresh token. So once you'll have an auth code, and then you have the ID token and the refresh token, then it will be returned to MDS. MDS will store it in its MDS internal topic, and that's when user is authenticated, and then MDS will pass on 200 OK to the browser, and it will set the session token in the form of a cookie, in the form of a set cookie header in the browser, which will help in maintaining the session. So that was about how the flow or the whole architecture we are going to see in our deployment. Now I'll invite Varsha to talk about how the deployment looks like.
OK. So let's get started on this journey of configuring single sign-on authentication method on this web-based UI tool that is Confluent Control Center, which would be deployed via an API-driven method that is Confluent for Kubernetes. So in this case, our identity provider would be Azure Intra ID. So with respect to SSO, there are three major components. So first one is the identity provider. The second one is the service provider, which is the CFK cluster in this case, the Apache Kafka Confluent Platform. And the third one is the principal or the user who is going to get authenticated via this SSO mechanism. So let's look at the essentials which we need with respect to setting up Azure Intra ID. So these are the checklists with respect to what all major essentials steps are with respect to configuring Azure Intra ID. So we require 5 major steps. So first one is with respect to registering the application, like you need to create an application. Second one would be to create a client secret, which is like, it could be an application password, which would be used with respect to requesting token from the authorization server. So in the flow just before this, where you saw MDS would be requesting ID tokens and refresh tokens in exchange of auth code, that is where this client ID and secret would come into play. Third one would be token configuration. So with respect to token configuration, there can be certain identity providers where ID token and refresh tokens are enabled by default as per your identity provider requirements in your setup. So in this particular case, we would be configuring certain claims under token configuration so that we can use group authorization with respect to having group claims in the tokens. So like Shubham said, that claims are nothing but data about the users which are passed in key value pairs inside the token. So group claim would be passed in form of, let's say, ID or let's say in the group name, whichever way you configure in the IDP. The fourth step would be to note down the IDP endpoints from the well-known ID configuration, or let's say the discovery URL from your Azure Intra ID end or the IDP end. So these endpoints basically would help you establish communication between the identity provider and the service provider. And the final step would be to configure redirect callback URL. So this redirect callback URL is the place where after authentication, the user is redirected back to. So once the authentication happens, like in the previous flow you saw, there were two parts. First was the authentication part. So once the authentication is done, there was a callback URI. So there the user would be redirected to, that is the application part. So this URL format, like you can see, it has the C3 host name. So Confluent Control Center, C3 is abbreviated as the Confluent Control Center. It will have the host name, port number, or let's say the IP or the port number, and it should be in this particular format, the API, metadata, security, and likewise. So these are the high-level major steps which you need to configure on the identity provider end. So let's see these steps into a visualized view. So this is where you go inside your Azure Intra ID and you register your application by giving it a name. And you can configure the redirect URI afterwards. Like even after registering the application. So redirect URI, depending upon how do you want to access your C3, you can configure that URL. So once your, let's say, CP cluster is up, you would have certain IP where you want to externally access it. So once it is ready, you can accordingly configure the URI. Or if you want to just configure it over the local host and the port, you can right away configure it while registering the application. Next up, the second step was to create the client secret, which would be acting as a client password, so using which the authentication actually happens. So this is the client's ID and secret, which you can create under certificates and secrets. So this value you need to note down right at the beginning, because due to like around within 10 seconds, this value would be in encrypted format. So we would see that in action in a while. The third step was to configure the token configuration, under which we would be adding group claims so that we can have group authorization. So accordingly, you can configure your ID token and access token to have the groups in the format of, let's say, names or IDs, whichever way you want to pass the group information in the token. And the fourth step was to have the endpoint details to establish the communication between your identity provider and service provider. So this is the discovery URL. So generally, this URL is in this format of well-known OpenID configuration. So you will get these 4 details, let's say the token endpoint. So this is the endpoint where actually the token is requested from. The JWKS URI would actually contain certain public keys in order to validate the signature of those JWT tokens. And the issuer is the URL of the authorization server, which is the Azure Intra ID in this case. And then there would be the authorization endpoint, where actually the authorization request is initiated to. So now let's see the final step, that is configuring the redirect URI. So redirect URI, like I said, it is the place where user would be redirected to once the authentication is done. And let's see this in action. So this is my Azure Intra ID. So once if we go here, so under app registration, you can click on this new registration, add your application name, and click on register. So I'll just show you the application which I already have. So this one is the C3 SSO. Okay, so that was the first step. Second was to create the client credentials. Click on this client credentials, and we would be able to create a new client secret here. So like I said, the value should be captured right at the beginning when you create the secret, because it gets encrypted. Okay. Next step is to configure token configuration, where you can add the group claims. So you can just add group claims accordingly, like ID token and access tokens. So SMA account name, if you want to pass the groups in form of names, and ID if you want to just pass the resource ID of the group in the token. So these are the 3 steps. The fourth one was to capture the endpoint details. So if we go here, so this is the redirect discovery URL, basically, the well-known OpenID configuration, so using which you can get those information. So all those 4 details which we need to establish communication between the identity provider and the service provider, we need to capture this so that we can pass it on the service provider end. The issuer and the JWKS URI, and this is the authorization endpoint. So once this is done, the final step was to have the redirect URI, which we will configure once our service provider cluster is ready. So which could also be done from the same place over here, where we were configuring client secrets. So this is where you just create your redirect URI. So add a platform, click on the application, whichever you want to use, add your redirect URI in that format of C3, IP, :port, and then the rest predefined part of having that particular API in it. So these were the essentials which we need for the identity provider end. Now let's go back to the...
Varsha, you can show the JWT token also.
Yeah, 1 second. Yeah, so this was a sample JWT token which Shubham was talking about with respect to having claims in key value pair. So this is a sample auth code which looks in this format once it's decrypted, which will have a unique identifier like JWT identifier issuer. Issuer is with respect to the Confluent. So the issuer URL which you saw, which we got from the well-known OpenID Connect configuration via that URL. So that value would be actually compared to this particular value in the claim. Then it will have some subject. Subject is with respect to the principal to whom this token is referred to. And accordingly, it will have expiration, issued time, and authentication time when the authentication actually happened. So these are generic claims. So the claims would actually depend upon which identity provider you are using, and accordingly, you can have those claims. Okay. So now let's move on to the next part of our journey, that is with respect to setting up the service provider, which is the Confluent Platform in this case. So we would be actually deploying Confluent Platform via the automated API-driven method, that is CFK. So I have captured all the steps which we discussed in this repo for your reference. So the first part is done. The second part is with respect to deploying CFK cluster, that is our service provider in this case. So let's see the steps one by one. So CFK is something called as CFK is an abbreviation for Confluent for Kubernetes, which helps you self-manage your on-prem data in motion workloads in any private cloud environment of your choice. So in this particular setup, we would be using a K-Raft controller-based Kafka cluster. Okay, so to give you a brief overview, so like we had 5 steps on the identity provider end, we have 5 major steps on the service provider end as well. So first up, we would be deploying Confluent for Kubernetes, which is an operator whose life cycle is managed via Helm, and it is deployed as a deployment resource in Kubernetes. Second up, we would be using OpenLDAP as the MDS identity provider here. So MDS would be using LDAP as the identity provider in this particular example. And next, we would be configuring certain secrets. So like we know, in Kubernetes, in order to pass certain configuration details, we create certain objects. So this secret is a resource object which we would be creating in order to pass certain credentials which we would be requiring with respect to having our Apache Kafka cluster set up. And the fourth and the foremost requirement is like the Kafka cluster should be an RBAC-enabled cluster, that is role-based access control cluster. And this RBAC runs with the primary mechanism of MDS. So in the diagram which Shubham showed, where you saw that OIDC authentication flow, it had MDS in it, that is metadata service. So RBAC runs on MDS basically. So MDS is the service, is the mechanism via which RBAC cluster runs primarily. And this SSO feature of having C3 offload user management to the external identity provider is available from Confluent Platform 7.5 and above. And the fifth step would be to have certain role bindings created on the C3, be it with respect to the users, or let's say if you are using group authorization, you can configure certain role bindings over the groups. So that based on the permissions which the roles have, you will have access to several resources in the C3, which is the web-based UI tool to manage and monitor your Apache Kafka cluster. Okay, so now let's see this in action. Okay, so first step, like we would be setting up CP via CFK. So we are seeing the steps which we need to follow to set up our service provider. Okay, so in this example, we would be configuring our Kafka CR, which would be configured via MDS, and LDAP would be its identity provider. So in this particular setup, I have deployed Kubernetes cluster over GKE. So you can have your Kubernetes cluster deployed over any private cloud environment of your choice. So first up, let's create a namespace resource in Kubernetes. Okay, I already have a namespace created. I'll quickly export the files which we would be requiring for this setup. I'll set the context with respect to having the namespace as this one, so that whatever commands we are going to execute will be executed for this particular namespace. Next up, let's deploy CFK. So this is the first step, basically, with respect to setting up our service provider. So its lifecycle is basically managed via Helm, and it would be deployed as a deployment resource. So as a result, the pod IDs will be randomly generated. Like every time you recreate the pod, it may have different ID. So let's set up the Helm chart for having the operator deployed. And we would now be installing CFK using Helm, and it will have this kraft enabled equals to true, which is basically the data recovery option, which gives you a cluster recovery option in case of accidental deletion of your cluster, where it is going to store your kraft cluster ID in the persistent volume and its corresponding PVC. So once the operator is deployed, we'll see the operator pod. So this is the ID which I was talking about, 7F844. So it could be randomly generated because it's deployed as a deployment resource. Now, the next step with respect to setting up service provider was to have an LDAP deployed, which is acting as an identity provider for the internal service, that is the MDS, over which the role-based access control cluster runs. That's the RBAC cluster. So this is also deployed via sample Helm chart. So I'm using the same file which we exported from the repo link. So let's wait for the LDAP to deploy. Okay. Let's check the status of the pod. Okay. Let's wait for it to come up before we proceed on to deploying our Kafka cluster. It will take a few seconds. Let's give it a few seconds. Yeah, there we go. So we have LDAP running. So next up, we would be configuring certain secrets, like secret resource, via which we would be passing our configuration inside our Apache Kafka. So since MDS is the primary service which is interacting with the OAuth server, there are certain self-signed certificates from the IDP end which needs to be imported to the MDS truster. So these are 6 certificates which I have actually converted into the PEM encoded format, and we would be generating this secret so that we can have network encryption over our CFK cluster. So this is the ca.pem where I have just concatenated these 6 certificates one by one. And we would use this to generate the TLS group 1 secret. So this is how, one by one, the certificates are being added to ca.pem, which will contain the list of all CAs, basically. So I'm just using the test certificates in this particular scenario. So accordingly, as per your environment requirements, you can have auto-generated certificates or self-signed certificates. Next up, we'll provide the authentication credentials which are being used by the various components in the Apache Kafka cluster. So if you remember, in the identity provider end, we created client ID and client secrets. So those we need to pass in this OIDC client secret.txt file, which we would be using to create the secret. So you need to update your client ID and client secret in this particular file. And along with that, we would be configuring SASL plane, basically, authentication mechanism in our Kafka cluster. So we would need to pass our user credential details in the JSON format, and accordingly for the clients, we need to configure certain credentials. So these details are being passed in this particular secret. Once this is done, there are certain credentials which we would require for an RBAC-enabled cluster. So we would just pass in the principal credentials which would be required. So first up, MDS token. So MDS service uses public key, private key pair to validate the bearer tokens which it gets from its identity provider, LDAP, for the authentication and the authorization purpose. So this authentication and authorization is the internal authentication and authorization of that Apache Kafka cluster. So along with that, we will pass in certain C3 MDS client credentials as well. And then finally, we'll have a Kafka REST credentials created. So this Kafka REST admin API is to help us manage Confluent role bindings or, let's say, Kafka topics via CR, the custom resource definition files, which are deployed as, one second, yeah. So which would basically be deployed as a stateful set. So Kafka and other components basically are deployed on this CFK in the form of stateful set applications. So now let's look at the sample YAML which we would be using to deploy our Apache Kafka cluster. So like you can see, we have Kafka configured with the MDS, and it would be using the LDAP as its MDS identity provider, and we would be passing in SSO configuration with respect to establishing communication between our identity provider and service provider. So we would pass the client ID and secret details via this credential secrets which we created, and these are all the endpoint details which we captured from the identity provider's well-known ID configuration or the discovery URL. So once this is done, we would be deploying our Confluent Platform. We would be applying this YAML. Okay. So, okay, on the C3 end also, in the CR, you need to configure that the SSO would be enabled over the OIDC protocol. So, having SSO in C3 has a requirement that it should have an OIDC-based identity provider. So, for now, we support only the OIDC-based identity provider for establishing SSO communication in Control Center on Confluent Platform. On cloud, you have both the options, SAML as well as OIDC. So let's give it some time to have the resources created. So I have just skipped to the part where the pods came up because Control Center pod takes a little bit of time to come up. So now let's look at the services of the Control Center. So because we need to access Control Center via the browser, so you can have both the options. Either you can have an external access setup where, let's say, it could be a load balancer type over a particular port, or you can access this C3 over the local host. So for accessing it over the local host, you would need to just do a port forward to that particular IP and port of C3 which you are using. So now let's see how the SSO login would look like. So before we log in, you remember the fifth step was to configure the role bindings. So without the role bindings, you might see that it will have a blank page. So we'll have to do that too. And before that, the redirect URI. So redirect URI, like if you want to have it over localhost, you could have done like in the beginning. Or if you want the external access, just configure that external IP once your cluster is up. And the role bindings which we created. Now let's see how the login would look like. So once you click, so this is the C3 front end where you get this login via SSO. And it would be redirected to the identity provider for the user to enter the credentials. So this is the authentication part. Between that, the MDS had to request that authenticate API. So those happened in matter of very few seconds. And the user is at now the identity provider end to enter the credentials. So it's again the multi-factor part, like to have an added level of security. So let's enter the code. And there you go. We now can access the C3 UI. So this is how we have very basic setup with respect to configuring SSO on Confluent Control Center in order to offload the user management to an external identity provider. So definitely there could be several customization to it as per your environment's requirement. And that is it from our end with respect to giving you a very brief overview with respect to how seamless the steps could be with respect to configuring your identity provider and service provider in order to configure the SSO authentication mechanism. So let's open up for questions.
For RBAC, where you have to configure, basically like for RBAC, like a cluster admin, developer roles will be there, right? Where we have to configure?
RBAC roles, you mean? Yeah, RBAC roles is something which is again at the MDS and RBAC level. So if you have seen, Varsha have created one C3 RBAC role binding YAML file, which she has applied via kubectl apply. So this is where, so you can create RBAC through either CLI or you can use C3, or also you can use a CR file to create RBAC.
So there will be certain predefined role bindings which we provide. So accordingly, you can create the role bindings.
Okay. How we can provide the RBACs for that particular control center user? Okay. You are using now the enter ID, right? Mm-hmm. For that, based on enter ID, we are getting the RBACs or something else?
So yeah, good question.
It's for basically C3 users who would be actually logging into via the C3 URL. So the role binding needs to be created on the user or on the groups, which the users could be the part of. So you can either use the Kubernetes resource by, let's say, via the CRD files, you can create Confluent role binding. So for that, you need to have your REST admin API class, REST class. So we used the default REST class over here, which allowed us to create the YAML file for the, let's say, the CRD file, which we use to create the role bindings on the particular user who logged into the C3.
So you mean to say for that particular, using that group, which is created in the Azure portal?
Yes.
For that, we'll create the RBACs, and based on like who are the user part of that group, they can access it.
Correct. Okay. Yeah. So you need to have users and groups configured on your identity provider end.
Okay.
You can also create it for the user. Now, for user, can you please show JWT IO once?
Yeah.
So for the user, let's say you're asking, let's say, how to create the role binding. So this is the subject. Now this is basically the claim or the principal name on which you have to provide the RBAC role binding. So in the C3 deployment, you will mention that what is my claim name on the basis of which I'm going to authorize my client. Now, if in the C3 claim you have mentioned sub, then it will use that. If you will mention email, then RBAC you have to provide on the basis of email. This is for the user. But for group, again, you have to use the groups.
Okay, the claim name is the
Yeah, you have to decide that what is the claim name, what you want to use as a principal for your RBAC role bindings. It can be the subject or it can be email or up to your preference.
And you can also get this information in the C3 logs. So I have a sample log over here, maybe to show you. So you will get this principle from the log as well. It would be logged in.
Okay.
So using this principle, you would just need to execute your command accordingly, be it via CRD or be it via CLI.
Okay, thank you everyone. Thank you.